This is the completed 7-segment display, but to get here we had to take 6 crucial steps. The analog input requires a 4011 IC or integrated circuit chip, an LED, and a resistor. This circuit is meant to demonstrate the function of the 4011 chip. Next is the NAND gate oscillator. The NAND gate oscillator is comprised of 2 parts. The first step demonstrates duration, and the second demonstrates oscillation and duration. The purpose of the NAND gate oscillator is to create a clock signal between the 2 capacitors, resistors, and the 4011 chip. The most important part of the decade counter is the new chip, the 4017. This chip receives the clock signal from the 4011 chip on its 14th pin. It then uses this signal to count from 1 to 10 and produces those outputs on its 10 pins. This is the final circuit. The 4510 IC chip receives the same clock signal as the 4017 chip does, only it receives it on its 15th pin. And instead of counting in decimals, instead this chip converts the clock signal into decimal counting. It then presents these signals onto its 4 output pins, which are translated into the LEDs. These 4 LEDs are able to count from 0 to 9 in binary, and it is just another good way to present the pulses. This is the final circuit. My circuit is actually a modified version of the original, which was designed for this DER. One of the 2 final chips that is required for this DER is the 4511. The 4511 has 4 inputs and 7 outputs. The 4 inputs are plugged into the 4 outputs of the 4510. Usually from here, the 7 outputs are tied to resistors and then plugged into the 7 different segments on the display. However, there was an issue with the issuing of our toolboxes, and a majority, if not all of the class, received common anode 7-segment displays instead of common cathode displays. This means that everything is inverted, and so as you can see in the picture above, the 0 turns out to be just presented as that dash in the middle, as it is the inversion of what is supposed to be on the screen. The solution to this issue is installing another IC chip. This chip is the 4049, and what it does is it inverts every signal that comes into one of the gates and outputs the opposite from it. However, the issue with this IC chip is that it only has 6 gates within it. So, to complement the last one, you need 1 NPN transistor as well. After properly hooking up all of the outputs from the 4511 to the 4049 and one of the segments to the NPN transistor, you can then carefully wire a resistor of at least 220 ohms, but I use 470 ohms, to the separate inputs of the 7-segment display. Make sure that the inputs that you are connecting to the inputs of the display are the correct corresponding ones, as if they are not correct on the 4511, they will not display the proper number. This is the completed circuit, and this is a video of it counting from 0 to 9. Thank you for watching my final DER of the year.